Here we are going to explore how to do THD analysis in Simulink, total harmonic distortion analysis in Simulink. So first, let's prepare a simple circuit where we are going to use a sine wave block to create a fundamental frequency and other harmonic frequencies also. For that, we'll go to library. In library, we'll go to sources. From sources, we'll take this sine wave block, we'll add it, minimize it. Now here we have a sine wave block. Open this block. There are various parameters in this block. We'll make amplitude as let's say 10. Now frequency we want to keep as 50 Hertz. Here the frequency is in radian per second. So what we'll do, 50 Hertz multiply by 2 into pi. So 52 pi is 50 Hertz frequency in radian per second. So let's okay. Now we'll have a scope. We'll run it for only 2 cycles. So here we have 50 Hertz frequency is fundamental signal. Now let's close it. Now again we'll go to library, math operator, and here we'll use this add block. We'll give amplitude as 1. Let's say we'll make it third harmonic, so 150 Hertz frequency. We'll make this one amplitude 1 and we'll make it 300 Hertz. Again we'll make the amplitude as 0.5 and 450 Hertz. Again amplitude 1, 600 Hertz. So here we have added various frequencies of sine wave with fundamental frequency with different amplitude, and now we are going to see the resultant output waveform. Let's run it. So here we have created the final distorted signal, and now it's time to do the THD analysis. For that we are going to use this power GUI block. So we are going to do the THD analysis of a final signal using FFT analysis tool, and that tool is part of this power GUI block. We'll go to this tools, and here you can see the FFT analysis tool. Now apart of this, have you ever wondered what is the use of power GUI block in Simulink? There are many simulations in which you cannot run the simulation without using power GUI block. So it's been really interesting to know the need of power GUI block in Simulink. So explore the need of power GUI block in my another video, and the link of that video is in description and here in I button. So now let's get back to this video. So we are going to do the FFT analysis. So for that, let's close it. We'll run it for 1 second. We'll open the scope, go to settings, logging, log data to workspace. We'll name this data as THD. Let's save it, close it. Now we'll take one more scope. In this scope, we are going to connect the fundamental signal, right? We'll open the scope, goes to settings, logging, and here we are going to give the name of this data as fundamental. Now let's run. Now let's open the power GUI block, tools, FFT analysis. When you open the FFT analysis, this type of power GUI FFT analysis tool window will pop up. Now here in this window, this section is to select a particular signal, and this left hand side area is to observe the selected signal. Below that, here we are going to observe the FFT settings, through which we are going to adjust the way we want to observe the FFT analysis, and that analysis part you will be able to see over here. So first we have two types of data, one is fundamental, the another one is THD. So we are going to do analysis of this THD. If you select the fundamental signal will be selected, and if you select the THD, the distorted signal you will be able to see. Now in the scope we are giving only one input. If we are giving multiple input, that multiple input you will be able to see over here. And then in that multiple input, if you are giving a three-phase signal, then individual phase could be selected from this. Now this is the setting for display. If you select the signal, entire signal is selected, and this red one is the selected signal. If you want to observe only selected signal, then you have to select the FFT window. So here we are going to select only signals. Now below that, here we have the FFT settings. The first is start time, from where you want to start the FFT signal. So it is starting from 0 0, that is why our selected signal is starting from 0. If you want to start from 0.5, then we'll mention 0.5 over here. So the selection of signal will start from here. How many cycles we want to include, and this is the fundamental frequency. The signal that we have created has fundamental frequency of 50 Hz, and here by default it is 60 Hz. So we'll update it to 50 Hz, and then we'll see the number of cycle. Here only one cycle is selected to do the FFT analysis. To make it more precise, you consider multiple cycle. Let's say here I am considering 5 cycle. So these are the 5 cycle which this FFT toolbox will consider to do the FFT analysis. Now the next thing is maximum frequency. The maximum frequency shows in this FFT analysis is 1000 Hz. If you want to go even further, you can modify it from here. Let's say if you want to go up to 2000, you can select it 2000 and click on display. So here you can see instead of 1000, a maximum frequency of 2000 is being updated. So let's make it 1000 again. So the next is maximum frequency for THD computation. Here we have two options, same as maximum frequency or Nyquist frequency. By default we have the Nyquist frequency option, and we are going to use the same one. The next is display style. Here you have varieties of display style. This display style is nothing but the way you are visualizing or presenting the FFT result. Here we have two options, either we can go for bar type visualization or we can go for list type visualization. Now if you observe this thing closely, you can see there are three types of variation. The first one is relative to fundamentals, the second one is specified base, and the third one is relative to DC component. So this relative to fundamental frequency means when analyzing the frequency component of a signal, the fundamental frequency is the lowest frequency component and serves as the base frequency for other harmonics. And displaying the result relative to fundamental frequency means that the magnitude of other frequency component will be presented in relation to the strength of fundamental frequency. So this can help you to understand the harmonic structure of the signal. In the next option, where relative to specific base, this is likely to refer to a chosen reference or a base frequency other than the fundamental frequency. By selecting a specific base frequency, you can analyze and visualize the harmonics and other components of the signal in relation to the chosen frequency. And the final one is relative to the DC component. The DC component presents the constant or a zero frequency component of a signal. It is often depicted separately in FFT analysis because it provides insight into the average or baseline value of signal. Displaying the DC component can be useful for understanding any DC offset presented in the signal. So this is why we have these three varieties of display style. And now I'm going to show you by selecting different display style what changes it makes in this FFT analysis. So first we are observing this bar view display. So this is bar view. The first one 50 Hz, it's our fundamental frequency. It's around 150 Hz. It's 300, 450 and 600. Now instead of this bar, let me select the list display. So here you can see sample time, sample cycles, DC component, fundamental and THD. This is 50 Hz FND, that represents our fundamental component. H2 that shows second order harmonics. H3 that is third order harmonics. Here 150 Hz is the third order harmonics. Here this 10% represents the relative amplitude to this fundamental frequency. The amplitude of fundamental frequency is 10 and the amplitude of this harmonics is 1. So simply it is 10%. After this we have 300 frequency, which is almost 10%. Then 450, 5%, and 600 is 10%. Now let me change the amplitude of harmonics and let's observe what changes it makes. Let's make the amplitude of third harmonics a little bit more. Let's make it even more. This one is 0.5, let's make it 1, and this one is 1. So let's reduce it to 0.5. Run. Display. So here you can see when we increase the amplitude of third harmonics, it shows the 30%. The same way sixth harmonics also increased, and this one also increased, and this one also increased. Now instead of this, if we select the bar, it shows like this. The magnitude is gradually reducing. Now we are going to select bar but relative to the specific base. Display. Here our specific base is 1. So you can see the difference in magnitude. Instead of this base value 1, if you change base value to 2, you can see the magnitude of all these things is reduced to half, right? So this is how by changing the base value you can have variations in FFT analysis. Now let's select bar relative to DC component. Display. Here actually we do not have any DC component. Let's add some DC component to it. Close it. Going to add a constant block. The magnitude of this constant block is constant. Now let's open this constant block. We'll keep the amplitude of this constant block as 1 as it is. Now let's run. Now we are going to select bar relative to DC component and display. So here you can see our DC component is 100%. So the fundamental is 10,000%. So here it will consider the amplitude of DC component as 100%, and with respect to that DC component it will show the magnitude of all other fundamental and harmonics components amplitude. If we select a list view, then you can see it is 999% larger. Now let's close it. You can even export this FFT analysis by clicking this export button. This FFT analysis will be exported as a separate figure. You can edit this figure the way you want. You can save it as JPEG or .png file format. You can even edit the properties of this image. Now let me show you. Close this thing. Go to this edit. Here figure properties. Go to the figure properties. In figure properties, you just select any of the component which you want to edit. Let's say we want to edit the title, and if you want to make any changes in this title, you can type it and make changes in this title. You can select different font style, you can change the font style, color, line style, line color. Anything you want to change, you can change it from here. You can even change the color of this bar. Just select this bar and from here you can give it the color you want. There are so many customizations you can do over here.